let's try this question. The cube of ice has sides length of 5 centimeters. As it melts, its volume decreases by 15% each minute. Right. Write an exponential function for the volume v centimeters cubed of a block of ice after t minutes. So we want to figure out volume. So a cube, let me draw a quick cube for you. How do I find the volume of the cube? Well, it's length times width times height. It's a cube, meaning they're all 5, right? You know what that means? So it's just 5 times 5 times 5, which is 75? No, 125 centimeters cubed. That's my initial volume. So my initial volume, if I write V for volume, T for time, the general formula should be K times A to the power of T, sorry, not N. So in this case, my original is 125 times A to the power of T, because that is initially, that's my original time. And I need to figure out that this is volume decreases 15% each minute. So it's a decay graph. So all I need to do is figure out my A value. My A value is always 1 if nothing happens to it. Decreases 15%. Well, if I change that to a decimal, it's 0.15. I have to decrease it, so take away 0.15, which becomes 0.85. So therefore, my A becomes 0.85. So if I rewrite the VT formula, it should be 125 times 0.85 to the power of T. Let me just double check that. Yep, that's exactly what we have. Oh, don't forget my units. Right, all I have to do is now find the volume. My T is 2 for the first question, so all I have to do is sub that one in. Alright, type in your calculators. And here's my answer. Second one, my T is 5, so I chuck that one in. That will be 55.5 centimeters cubed. Right, all I have to do is graph it now. I'm done. Right, let's graph it. So my T is in minutes. My V is in centimeters cubed. Let's give it a graph. My highest value that I need to do is 125 and then 55. So I just got to make sure that fits. Alright, so I'm not going to fit it. Maybe I'll just do 20, 40, 60, 80, 100, 120, 140. And then I've got to do 0 to 5 minutes. So 1, 2, 3, 4. I'll make it a bit larger. 1, 2, 3, 4, 5 minutes. Right, let's graph it. When it's at 0, it's 125. So about here. Oh, about here. When it's at 2 minutes, it is about 90. When it's at 5 minutes, it's about 55. So approximately here. So this is what my graph looks like. I'm just going to move that so it looks like it fits. I don't like that. So let me just redraw that one. So it should fit in like so. And just write your function. And then you're pretty much done. So what's my function? Right, then you're done.